you for listening to this online. Today we're going to be talking about the respiratory system. So the question that I would ask if we were in class and make you wait for is, what is the respiratory system? So I'd like you to take a minute wherever you are and try and write down at least 3 things that you already know about the respiratory system. All right, so the respiratory system, as you hopefully already know, takes in air from the outside environment, allows exchange of oxygen from the outside environment and carbon dioxide from the body, so that the oxygen in the blood is replaced and the carbon dioxide is released. Air starts at the nose or mouth, goes down the trachea, and ends up getting a gas exchange in the lungs. Now, we're going to talk about each of those parts, but lining most of this is the respiratory epithelium. So when we look at the respiratory epithelium, we've already had a question on this before. The respiratory epithelium is going to be a pseudostratified, ciliated columnar epithelium. And you should know that because it needs to produce mucus, and it needs to have cilia to produce turbulence in the fluid, in this case air, in those passageways. Also, in that respiratory epithelia are goblet cells, which are specialized for producing mucus. Mucus is important because it keeps those passageways moist, despite the fact that they're constantly being exposed to the air, and it also helps trap particles and viruses and bacteria and anything else that you might be inhaling. So the respiratory system starts at the nose, and the nose is very important because not only does it take in air, but it starts processing this air so that by the time it reaches the more delicate passageways lower in the respiratory system, it's not going to damage them. So the structures that are important for this start at the very outside with the hairs. The hairs, which are generally covered in a thin layer of mucus, are sticky and they act as an air filter. They capture a lot of the particles, especially the larger particles, that come into our nose. If you've ever gone walking in a really dusty environment and then blown your nose and had nasty brown gunk come out, that's all the stuff that the mucus and nose hairs caught. Once it's passed through those nose hairs, it goes into the nasal conchae. Nasal conchae disrupt the flow of air and cause turbulence. Now, the benefit of this is that it allows the air to come in contact repeatedly with the moist surfaces in the mucus. The air outside is very dry compared to anything in your body. You've certainly noticed this if you're outside in the winter and that dry air is constantly drying out all of your tissues, drying out your skin, drying out your nose, drying out your mouth, drying out your eyes. So this allows the air to hydrate somewhat in your nose before it gets down your throat. And this is why if your nose is stuffed up and you're breathing through your mouth, your throat gets sore, because that air isn't being moistened to the same degree as it would be in your nose. So these conchae, the air comes through. It can pass through any of these passageways, but either way it's going to form turbulent whirls that will pick up more moisture. And the air comes in through your nose, and of course it can also come in through your mouth, and then it goes down to the back end of your nose, where we're going to talk about in a moment, the nasopharynx at the very back of your nose, and the internal nares behind the conchae. Now, at the back of the nose here, we have the internal nares, which are just the posterior nares, which are just the area that the air passes through at the back of the nose, the nasal cavity, and then it passes into the nasopharynx.
And this ends the first part of today's lecture.